Alright, hi, this is Will Scott. I'm doing a demonstration of this hovercraft I built for the lab. This one's pretty simple, just built out of a CD, attached to a balloon by a water bottle cap and a whole bunch of duct tape. Balloon's inflated right now, and the idea is that when you release this valve, the balloon will start to deflate and the craft will start to hover. So what this lab is trying to demonstrate is the fact that friction is a force that works in the opposite direction of other forces. And the whole point is that it's based upon the normal force and the coefficient of static friction. And since the normal force is based upon, typically on a flat surface, the weight of an object pushing down, a hovercraft is interesting because it reduces that weight to nearly zero, and therefore reduces the normal force, and reducing the friction. And so you can see, I can apply a slight force. Well, there's not a lot of friction on this, but I can apply some force and it doesn't really move. And that's because while it's not hovering, it's got a decent amount of friction on it, which resists my use of force. And I can increase the amount of force I can apply up to a certain amount, and that's because static friction is typically represented as an inequality because it repels up to a maximum value. Alright, so now I'm going to open this valve. Sorry, that took two hands. And as you see, the hovercraft, as it moves, has an extremely low coefficient of friction. Actually, the balloon deflated, but you saw that it was moving around with almost no input from me. And so that's showing how when there's no force to resist, no force such as friction that would resist an applied force, an object will not decelerate, which demonstrates Newton's first law of motion, that an object in motion will remain in motion unless acted upon by an outside force. And so hovercraft's an excellent demonstration of that. Thanks for watching.